Okay, we're back for week 2, Swyk 1, all right, of this lesson 2.1. Simplifying and combining like radicals is our first topic. First of all, what is a like radical? It's got to, first of all, it's got to have the same root index. So you can't, be adding a square root and a cube root. They both either have to be square roots or both cube roots, or something like that. Secondly, the same values under the radical. That can also be written, I guess I should have written the radicand. I know, cool word, you can use at parties. Trust me. Anyway, so the part under the radical has to be the same. So when I look at this, I see like radicals. Now, I am going to go over here to this example right here because this really kind of helps you think through the process. You've seen like terms before. 6x plus 7x makes 13x. You never messed with the x. You only combine the coefficients. This is no different, okay? This is not the same as multiplication, right? If I were to multiply these two things that you're looking at in front of you, you would get 42x squared. So you would have to add the exponents, but nothing is happening when you're adding these two like terms. So nothing's going to happen here. We're just going to get 13 radical 6. That's it, folks. Can't do anything more with it. There's no perfect squares trapped inside of radical 6 that could be simplified or brought out. All right, cool. And then, yes, that would be the answer to the question, if you're wondering. Oops, didn't need that mark. All right, moving on. So now we're dealing with subtraction. Same thing. 3 radical x minus 7 radical x is negative 4 radical x. Don't make it more complicated than it is because that's really all you can do. There's no perfect squares trapped inside the radical. What if there are perfect squares trapped inside the radical? I'm glad you asked. Because here's a situation where that's true. So we started off with radical 27. All right, now radical 27 has a perfect square in it. And that would be 9, right? Remember your perfect squares, 4, 9, 16, 25, 36, and so on, okay? Those numbers are the numbers I'm looking for to see if they go in. And I want to look for the one that's the biggest that goes in. Now, are there other ways to do this? Could we look at factor trees? Yes. I do not like factor trees because people lose information in the tree. If you want to do something different, we can do a process called upside down division. Take the number 27, for instance. You want to start by looking at the smallest number you can think of that goes into 27. I should preface that. Smallest prime number, such as 2. 2 does not go into 27. So I move on to the next prime number, 3. 3 goes into 27 9 times. Then I try again. Does 3 go into 9? Now, if the answer is no, which I know it's yes, but if the answer is no, then I would go on to the next prime number, like 5, and then 7, and so on. But we know 3 goes in 3 times. When you hit a prime number at the end, you know you're done. This is in my opinion, this is a way for you to not have an issue. So here you can see a perfect square, right? It's a group of 2. If this were a cube root, I would have circled groups of 3. Which means I would have circled all the 3s. But I didn't. So, one of them is coming out. The other one is trapped inside. So this is one way to look at it. Now, I personally think it's just as easy to find the largest perfect square which goes into 27, which in this case is 9, and separate it with square root 9, square root 3. So what I have are basically in one category I have the perfect values, and in the other category I have the leftover values. Okay, and so the 3 in this case was leftover, the 9 was perfect. When you take the square root of 9, obviously you end up with 3. So 3 radical 3 is the same thing as the square root of 27. All right, now when you go to the square root of 108, you look for a bigger number. Well, you look for the biggest number you can find. In this case, it is 36. It goes in 3 times. Therefore, you can take the square root of 36 and get 6 radical 3. Now it's easy to see that they are like radicals, and I can add them together. 9 radical 3 is the final answer. What? Here's more of the same type of thing. You've got radical 27 plus radical 108 minus radical 3. Since the numbers were so similar, I just wrote it out. Very similar to what we did before. Just remember that when it's a minus radical 3, there's really a 1 in front of it, right? So you're taking 1 away. So 3 plus 6, take away 1, makes 8 square root 3, or 8 radical 3. So that's the kind of idea of what we're doing in this. Once we get to cube roots, we'll be thinking about perfect cubes and not perfect squares. So just thought I'd show you this, and that's the it. You can move on and get the Swyk 1 done.